Regression is a statistical process for estimating the relationships among variables. This is often used to make a prediction about some outcome. Linear regression is one type of regression that is used when you have a continuous target variable. For instance, in this case where we're trying to predict the number of umbrellas sold by the amount of rainfall. The algorithm definition for linear regression is y equals mx plus b. Logistic regression is a form of regression where the target variable, or the thing you're trying to predict, is binary. So just 0 or 1, or true or false, or anything like that. Why do we need two different algorithms for regression? Why won't linear regression work for a binary target variable? Imagine this plot where we're just using one x feature along the x-axis to predict a binary y outcome. This is what that kind of plot would look like. If we use linear regression for a binary target like this, with a best fit line that makes any sense. Linear regression will try to fit a line that fits all of the data, and it will end up predicting negative values and values over 1, which is impossible. Logistic regression is built off of a logistic or sigmoid curve which looks like this S-shape here that you see on the right. This will always be between 0 and 1, and it makes it a much better fit for a binary classification problem. What does the equation look like for logistic regression? Basically, it just takes the linear regression algorithm for a line mx plus b, and it tucks it up as a negative exponent for e. So our full equation is 1 over 1 plus e to the negative mx plus b. That makes it a good fit for binary classification problems. When should you consider using logistic regression? First, you should consider logistic regression anytime you have a binary target variable. That's what this algorithm is uniquely built for. Next, logistic regression is one of the more transparent algorithms, in the sense that you can gauge the individual predictors by odd ratio. If you're interested in feature importance or having a better understanding of what's going on within the algorithm, then you should consider using logistic regression. Logistic regression doesn't do very well with messy data such as data with too many outliers, data with too many missing values, or data with relationships that are too complex. What logistic regression is great for is an initial benchmark model on a binary classification problem with fairly well-behaved data. It's relatively flexible, and it's very fast to train. While it doesn't usually generate the greatest performance, it does set a very nice benchmark to start. However, you should not use this algorithm when you have a continuous target variable. Remember that S-shape between 0 and 1? That would not work very well for the umbrella rainfall example that we saw before, or really any other modeling of continuous variables. Logistic regression also shouldn't be our first choice if you have a massive amount of data. There are other algorithms that really shine when you have a ton of data. There are many shapes of data. There is something called fat and short data, that's when you have lots of features, but very few rows. Or you can have long and skinny data where you have a lot of rows, but very few features. I will probably avoid using logistic regression in either of these cases. In summary, logistic regression is a great tool for a fast, transparent baseline model for a binary classification problem. It doesn't do well with a lot of data or particularly messy data.